So, good evening, one and all. Again, this is Dr. Ramakrishna, co-coordinator, along with Dr. B. Raghukumar, coordinator of this wonderful learning program. Welcome you all to the day 3 session of this wonderful 2 week CICT sponsored Atal FDP on applications of mechanical engineering. Today, we glad to have an eminent speaker, Dr. Sanjeev, to share his knowledge on the importance of IoT for mechanical engineers. Dr. Sanjeev Rajput is currently working as an assistant professor at the Department of Mechanical Engineering in NIT Raipur since 2021. Prior to this position, he is working as a senior research associate at the Institute of Material Science and Technology of Technical University of Vienna, Austria, for more than 3 years. He also worked as a research associate on FWF project at the Institute of Material Science, Farming and Joining at TU Graz, Austria for a year. He obtained his master's and PhD degree in the field of material design and welding metallurgy from IIT Roorkee. His research interest area is welding and joining, thermomechanical processing, material design, microstructure properties, correlation, kinetic precipitation of materials, FEM simulation, additive manufacturing, IoTs, and Industry 5.0. He has published 2 books, one special issue, and more than 40 research papers in reputed journals, international journals, conference, and book chapters. So we are very glad to have you here, sir. So I'm handing over with this brief introduction. I'm handing over the session to Dr. Sanjeev.
Sir, I think the voice is breaking. So maybe my voice is coming clear.
Yes, sir. Yeah, you are audible and very clear.
So I think it is not the problem from my side. Okay.
Yeah.
So thank you very much for the brief introduction. So today our presentation on the importance of IoT, Internet of Things, for the mechanical engineers. And the purpose of this presentation to describe about the mechanical engineer. First of all, we have to understand what is the capability of mechanical engineer and how the mechanical engineer can use Internet of Things in the application. So this is the content of my presentation. First of all, we understand about the mechanical engineer.
Sorry to disturb, sir. Can you make your presentation?
It is moving, not coming.
Raghu sir, I think you have to do something. I think
it is not working, sir.
No, actually, that banner only visible, not your presentation.
Sir has to share the screen.
Can you stop it once and then?
Sir has to share the screen. Sir Sanjeev sir, please share your screen.
Yes, sir. I am sharing again. Now is it visible?
Yes, sir. Perfect. Go ahead.
Okay. So today our presentation topic is importance of Internet of Things for the mechanical engineer. So why it is important for the mechanical engineer and how the mechanical engineer take help this automation facility and who can increase the efficiency of the power plant and also in the for the social work. So the content of this presentation about the mechanical engineers, Internet of Things introduction, what is the history behind that of the IoT, status of technology for society, and what is the current status and future prospect of IoT, and how many types of IoT on that basis we can decide for the particular application, and what is the potential of IoT and what are the challenges of implementing effective IoT system and the effective procedure for implementation of the IoT. And the next point is the innovation solution for future IoT. So what we can do there. And IoT application for tomorrow. And what is the current status today. An application of IoT in mechanical engineering, because we are talking about for the mechanical engineers,
7 to
and
9.
required component and software for the IoT
Daily
system,
evening
and
7
what
to
are
9,
the
mali
challenges
9:30.
we are facing still in the
సరే
IoT
మన
system.
పీవీపీ కొడితే వేరే వాళ్ళని చోట ఇవ్వడానికి ఉండదు. సరే అట్లా
So
చేయండి. కావాలి
the
కొడితే నేను
mechanical
వస్తాను.
engineer, as we know that what is the purpose of mechanical engineer, as we understand by the anticipating and solving tomorrow's problem today. Okay, so the purpose of that, we want to reduce the effort and we want to find out anyhow what is the solution of that. So what is the mechanical engineer? Mechanical engineers play an important role in the following area, such as manufacturing industry,
ఫ్రైడే
automotive,
ఇచ్చేస్తారా?
aerospace, biotechnology,
సరే.
and like the computer and electronics, automations, and more.
ఇది ఇస్తాడేమో అనుకో.
They design, develop, build, and test all sort of mechanical devices, tools, engines, and machines. So the mechanical engineers are able to design and manufacturing everything from small parts like miniature connectors to large machine tools like drill press. They take a product from start to finish and design for aesthetics, functionality, and durability purpose. Okay, so what does a mechanical engineer do? What is the exactly work of that? That we have to understand. On that basis, we can think in the direction of IoT. So it is the mechanical engineering is the branch of engineering that involves the design, production, operation of machinery by the physics, engineering, mathematics, and material
అవునవును
science.
స్టిక్కర్లో ఇచ్చేస్తారు. అవును కరెక్టే. స్టిక్కర్
Mechanical engineering is seen in area of such as the composite, mechatronics, and nanotechnology, and often overlaps with manufacturing engineering, metallurgical engineering, civil engineering, aerospace engineering. So many branches. They are always the use of the mechanical engineering, because of, as we know that without any machine they cannot do anything. So everywhere the mechanical system is required. If the machine is working, it means the mechanical system is put there. So in that condition, our requirement is very, very high. In order to design and manufacture mechanical system, mechanical engineers need to have deep understanding of mechanics, dynamics, thermodynamics, electricity, and structural analysis. They also need to be able to use computer, as we are using currently, computer aided design, computer aided manufacturing, to produce and analyze their design on the by using the different type of software like the ANSYS, SolidWorks. So many softwares are available today. In today's world, computers have changed how mechanical engineers do their job, allowing complex analysis to be completed in a matter of seconds versus the day, week of hand calculation that were once the norm. However, mechanical engineer will still use industrial production equipment, material science handling, and electrical generators to produce a fully refined product. And using calculus and trigonometry is needed when confronted with in the more complex or analytical portion of the occupation. So it depends on the situation. But now the question is, are mechanical engineers happy or not? In this condition, if we say, then yes, of course, the status of that 3.7% out of 5. So it means more than, so highly satisfied people are available in the mechanical engineer, because of they are getting so many opportunity by adding the so many additive manufacturing streams, and also the CAD, CAM. So many streams are available in the current days. But now thing is, what is the IoT? and what we understand by the IoT and where we can use this. So by the definition, the Internet of Things is a network of physical objects or things. So things is nothing but that is the object where we want to implement our technology embedded with electronic software, sensors and network connectivity, which enables these objects to collect and exchange the data. It allows objects to be sensed and controlled remotely across existing network infrastructure, creating opportunity for more direct integration between the physical world and computer-based system that mainly responsible for the resulting in improved efficiency, accuracy and economic benefits. That which one is the one of the most important part. If we are not belonging from the technical background, then we can understand in a simple language, non-technical explanation of the Internet of Things. How do we read an e-book? It might be on desktop or on mobile phone, maybe on our tablet, but whatever device you are doing, it is most likely connected to the internet. Where an internet connected is a wonderful thing. It gives us all the sort of the benefits that just were not possible before. When we talk about two decade or 3 decades before. If you are old enough, think of your cell phone before it was a smartphone. You could call and you could text only the messages. But now you can read any book, watch any movie, listen to any song in the palm of your hand. So the point is that connecting things to the internet yield many amazing benefits. Why the IoT matters for the mechanical engineer? When something is connected to the internet, it means that it can send information or receive information, or both can parallelly. This ability to send or receive information makes things or smart. Let us take an example of the smartphone. Right now, we can listen to just about a song in the world, but it is not because of we have that song. It is happening due to this song is already stored in the cloud. It because every song in the world is stored somewhere else, but your phone can send information and then receive information. So send information and receive information is the important thing. To be a smart thing does not need to have a super storage or super computer inside of it. It just need access to it. All things has to be is correct to super storage or to a super computer. Okay, no sir. Okay, I was talking about why the IoT matters, and now in the Internet of Things, all things that are being connected. So how those matter? So on that basis, we can understand things that connected information and then send it. Things that receive information and then act on it. Things that do both. So all three these have enormous benefits that compound on each other. So what is the history behind that of the IoT? We understand in the simple word, but what is the history? Who make this? Who understand about the IoT? IoT was originally introduced by the Auto ID Center at the MIT, which is one of the reputed institute. Those have done in 1999, where an important effort was made to uniquely identified product. The result was known as the electronic product code, which was then commercialized by the EPC Global. It was created to follow the auto objectives in the industry with the European article numbering, Uniform Code Council, as a partner to commercialize auto ID research. Mainly, it is the EPC, that is the electronic product code. A thing or object is any possible item in the real world that might join the communication chain, that we may look in the right side figure. In this figure, the initial main objective of the IoT was to combine the communication capability characterized by the data transmission. This was viewed as the internet, also known as the network of bit. So you may look in the network of bit. So in the EPC networking, we are connecting the all things at a place. So we are giving the input and getting the number of bits. And atoms, we are considering our physical things. Later, some of the researchers work in this direction, and they found in 2005 a new technology, that is the ubiquitous, which is the extension of the Internet of Things at the initial stage. So it is done by the International Telecommunication Unit, introduce a new access of the ubiquitous network path. The purpose of that to complete the existing anywhere and anytime connectivity. In the figure, you may look anytime, any place and anything connectivity. When you will look in the direction of anytime, there we are, I mentioned here the daytime, nighttime, outdoor, indoor, or on during the moving condition. So you may use this thing at any time connection. So no connection will break. Any place connection, when we are connecting with the PC, indoors, away from the PC, outdoors, or during the moving condition. And the third thing is anything connection. So between the PC, human to human interaction, not using a PC there. So human to things, using generic equipment, or things to things, that is the T to T. This figure represents the ITU view of ubiquitous networking, adding anything connection to the connectivity anywhere and anytime. By adding the anything connection, access new source of information are introduced in the connected network, and this enables new service exploiting the newly introduced information in the network. So in this figure, you may look the human to human connection, where the PC, TV, and also the personal things are connected, and the mobile phones are connected when you are looking in this direction, the vertical direction. And the other thing, these are the electronics network, and where we are standing human to object or human to object communication. So both are communication when we are working in this direction. So the human to human communication and object to object communication. So we are using the IP or other different things. So what is the status of technology for society? In starting, this is the society. On this basis, I gave the society 1.0, 2.0, 3.0, 4.0 and 5.0, like the industry 4.0 and 5.0. So in the starting, we were using the computer by the connecting cable, that is the host, and the later we are using the internet and we are connected by the Wi-Fi system or maybe by the web internet connection thing. And in the society 3.0, that time the mobile internet connection, so we can also connect our mobile phone and also the computer host. The next thing, the society 4.0, there what is happening, we are connecting our family member as well, and with the mobile phone and also so human to things. And the industry no, society 5.0, there we are connecting also our car, by which how we are acting this, when we are at the inside the home, that time our car is outside, then we can click a button of that car and it is already connected by the Wi-Fi system, so we can open the door or we can judge exactly where is the location of our car. Similarly, we can look the coffee machine and also the refrigerator, home light, so we can consider it is like a smart home. So many things are connected in the current days. We are talking about the Alexa. So most of the person are familiar with Alexa. Maybe they don't know about the which kind of technology where they are using, but they picked some of the limited words in that. So the Alexa understand to those things. On that basis, that the machine, the system allow to response. So receive the information and deliver the response. So the current status and future prospectus of IoT. So what was the status in starting? When we talk about in the 2003, there the connected device per person 0.08%, and the total world population was the 6.3 million, and total connected device was only the 500, which is lesser than the public. But in 2010, the ratio is increased and the higher connectivity than the people. So this growth is very, very fast, or we can say the drastically change in that we found. And during the corona, we can say in 2020, it is increased approximate 4 to 5 times, or maybe later it moved very, very fastly, as we can look by the right hand side figure. Okay, so how many types of IoT? If we want to work in the direction of IoT, then how many types that we have to understand. On that basis, we can decide which direction will be the suitable one. The IoT system can be classified in several ways, on the basis of scope, by sector, by the implemented networking protocol, and by the direction or the flow of data. So these four things, on that basis we decide our the IoT of the system. First of all, we discuss by one. First one is the flow of data. So in the flow of data, IoT system can be identified by the direction of flow of data. For example, this figure shows an IoT system used to remotely interact with a group of robotic camera for the TV and film industry. By this example, we can understand this classification: remote monitoring, data flow from things to the IoT client, remote controlling, we can control also by that. So remote commands from remote commands flow from user to the devices. Things to thing, data is shared among the IoT devices. Combination, it means the combination of two or more. So mixture of two or more of the above system. By understanding the direction of the flow, several decisions are affected. In remote monitoring, IoT system, the focus would be implementing effective dynamic analytic algorithm to create the best possible insight from the raw data. Even in the remote controlling system, the client must capture user interface and send them to the IoT devices, who themselves would be programmed to expect these commands and act them when they arrive. While in the things to things system, the IoT device would need to be programmed and configured to exchange, share, combine the raw data for the collective optimum performance. When we are talking on the basis of scope, the focus on the type of scope, the classification of focus on the type of scope or things being connected to the cloud. Example included the following: Internet of nano things, covering nano scale devices; Internet of mission control things, that never we do, but it is controlled by the military and we use for the purpose of military and police, so they can use only this data. Internet of mobile things, this is for the general purpose, this as our public is using for the for on the move IoT devices. Internet of robotic things, that we used in the industry. Though these classification experts from those area, that is nanotechnology, mission control, robotics, could from their work together and develop more efficient IoT systems. When we talk about the sector, so this classification focus on the industry in which the IoT system is implemented. For example, agriculture, where the precision agriculture, vertical farming. The purpose of vertical farming, you may look in the right side figure. The vertical farming is one kind of practice of growing crops in vertical stack layers. It often incorporates controlled environment agriculture, which aims to optimize plant growth and soilless farming techniques such as hydroponic and aquaponic and aeroponic. Last 2 years I understand too much about this, and many people are moving in this direction. Even those are working in foreign abroad, those are also currently working in this direction, the hydroponic and aquaponic, as well as also the aeroponic direction. The industrial, on the basis of industry 4.0, our prime minister also discussed about the industry 4.0 and when he visited in the Germany. So that time he also discussed more about this. The smart factory, industrial IoT, where the very fast speed is required at a stable place. Social, smart homes, connected appliances, Google Home, etc. Infrastructure, water management, smart cities, vehicle, etc. Also, during the corona, some of the hospitals, or we can say the healthcare system, work in this direction. Otherwise, they just maintain the social distancing between them. And so many sectors. By networking protocol, so which kind of networking protocol we have or we can use for the IoT connection? On that basis, we also decide this classification focus on the type of network protocol implemented, as we talk like the cellular for the mobile phone, moving and portable system, LAN and PAN, local or personal area network, local area network or personal area network, like we use the Bluetooth and Wi-Fi to connect our smartwatch with mobile phones, and LPWANs, so low power wide area network, that is known as some of the company, the LoRa is developing, and mesh network formed a mass of nodes collaborating to reach an internet gateway, such as maybe some of the person also heard about this, the Zigbee. The choice of network protocol often depends on the application requirements, whether the device would be fixed or mobile, indoor, outdoor, etc. It also depends on the broadcasting environment, such as the volume of the data packet needed, frequency of broadcast, and type of data required, and other considerations as well. The next thing is the IoT gateway. The purpose of that, in the early days of the IoT, the purpose of an IoT gateway was similar to the network card in a computer system to establish a connection to the internet and facilitate data transfer. However, with the development of network ready controller such as or Arduino, Raspberry Pi, Beaglebone, and Node MCU. In India, many people are using the Arduino and Raspberry Pi because of those are a little bit cheaper than the other, which are readily connected and can be easily programmed for the IoT purpose. The need for the dedicated network card reduced significantly. Today, the role of IoT gateway is to act as the traffic police and govern the flow of data for optimum system performance and responsiveness. By monitoring the flow of information coming from each connected endpoint and prioritizing critical data, IoT gateways can be prevent system overloading and traffic bottlenecks. So, what is the potential of IoT? In the above figure, where it represents the classical form of the IoT, where IoT device capture and broadcast raw data to the cloud, while data analytic algorithm converts the raw data into the valuable insight, which is delivered to the IoT clients for us to view the use. In reality, IoT system can be much more than that, as we can look in the below figure. In this figure, we can look. IoT system can benefit organizations in three ways: streamline operation, reproducing data, and data monetization. So we may look some of the example in this direction. This is the city map where we have the some of the buses. So in this figure we can look or we can see that one of the company operate 5 buses in a city in 5 different routes. But due to rising cost, the company want to drop one route and focus only on the remaining routes. The question is, which route should follow for the company drop? So company will drop, and to which route should they assign the extra bus? Once again, without reliable information, the bus operator will have to guess and hope, and mistake will be very costly. Therefore, the company decide to perfect route using the IoT facility, where the IT system could identify passenger volume on the basis of hourly, daily, weekly, and month basis. Therefore, the system could locate in demand route, peak hours, traffic patterns, so driver performance, and so many things. Based on this data, the operators could make informed decision, drop the least in demand route, reward excellent driver, capture user feedback, minimum their loss, and maximize the use of their buses and driver. The operator could also make dynamic change to their operation to capitalize on passenger volume and patterns. Since they already know their passenger volume, trends and patterns, they can reroute buses and driver any time in the day, week, month to match passenger pattern. Not only they be able to reduce the cost of the maximize profit. So the potential of IoT in the direction of reproducing data. So how we can reproduce the data? There we was giving only the input. So in terms of the agriculture, IoT system can be used to capture the field data, like the water level we can measure, fertilization and moisture level. So and use this information to streamline agriculture operation. For example, direct resources such as worker, machine, and consumables to where needed. These systems are example of the precision agriculture system. However, the same data can be used for another purpose entirely, for the development and implementation of the smart contract. So the third one is the potential of IoT, the data monetization. So how we can do the monetization of IoT data can be achieved in two ways. One is the after the fact and other one is the through a dedicated system. So these two approaches are very similar in result. They only differ in implementation, how we are implementing this thing. After the fact means the company decide to monetize its IoT data after they had already developed a working IoT system and used it for another purpose to create auxiliary source of income for the company. A dedicated system means the company purposely built the IoT system for the sole purpose of selling its data as the commodity. Perhaps the company identified a potential market for some information like the passenger volume or food traffic. So they built a dedicated IoT system to develop that information and sell it to the potential market. So the potential of IoT in different sectors, that is, it is the status of that. So in the aviation, power, healthcare, rail, oil and gas. In that segment, the commercial gas-fired generation, system-wide freight, explanation and development. So almost they are saving 1%, and this is the over the 15-year estimated value turnover of that. So what are the challenges of implementing effective in the IoT system? We looked as we looked in initial detail in the previous slide about the benefits of the IoT. While these benefits is not straightforward, there are several challenges we need to navigate and avoid. Understanding these challenges is the first step towards achieving that. Now we will review the challenges here while implementing IoT, while the later we will discuss about the overcome and eliminate these challenges. So the multidisciplinary nature of IoT is required. To full understand the implement IoT, one needs to working knowledge in the following area. So we have to knowledge about the electrical and electronics engineering, metronics or electromechanical engineering, software engineering, especially on programming and web application development, sensor actuator. This is our initial part. The controller selections, setup and programming, networking setup and configuration, knowledge of economics and business development. If we do not have the knowledge of the following area, then we have to hire the person and or we have to take the help from them. The multidisciplinary nature of the IoT is difficult for the beginner to enter the field of the IoT. This is further compounded by the very nature of engineering education. which usually focus on the specific discipline such as mechanical, electrical and electronics or software engineering at a time. But in the current time, many students are targeting in the all direction. They are also understanding about the additive manufacturing and also the C++, Python language. So many languages they are understanding. So what is the exactly condition? How they write down the program in that? Okay, so the next slide, outdoor application, IoT application. So we will understand on the basis of the open field agriculture. As discussed before, in precision agriculture application, IoT devices are placed in the agriculture field to collect that would be used to streamline agriculture operation, as we can look in this figure. For the sector and primary challenges is to establish a reliable internet connection for the IoT devices in the field. So in that field, to collecting the field data. Often these devices are expected to be placed in isolated rural area with a poor network connection and no access of electrical power. The same applies to water management system, which manage water flow in a small canal through a network of autonomous and remotely monitored operated water gates. So often found in the rural environment. Another challenge is protect the IoT device from the element, against heat from the sun, water from the rain, and attacks from the animal as well in the open field agriculture condition. The important is the industrial IoT application. In this direction, I am also working. I am working in the direction of Industry 5.0. Where in the first of all we will understand the Industry 4.0. The situation is here the opposite. The outdoor sector, there would be no problem powering of IoT device because of everything is inside or in a roof or in the different buildings. So connectivity is very good. All devices would be placed indoor where the power connection are readily available. Nevertheless, the industrial sector has to its own challenges. So which kind of challenges? Manufacturing and industrial machines are expected to operate for extended operational hours, proceedings hundreds or thousands of parts per machines per day, performing various tasks, processing, inspection, finishing and quality and also the packaging. So it is the part of the inventory. Therefore, the sheer amount and complexity of data would be huge. In that condition, it would need to be broadcast as fast as possible. For that, it is required the high-speed internet or high-speed broadcasting. Very powerful connection is required. Another challenge is security and privacy of data. For most industry, manufacturing data are priority and cannot be exposed to the competitor. So, added layer of security measures against cyber attack are a must for industrial IoT application. In the normal purpose, we can use. So, because of suppose we are using in our home or we are making the smart home, there we are just on off the light or we are just measuring the temperature of our geyser. We are just taking the information. That information also definitely can be taken by the other person or by the hackers especially. But in industry, we have to provide too much security, so we can save by the attack. So I was talking about the Industry 4.0. Here we are, everything is connected, and so now in this condition, no connection of the people with machine. But what we are doing in the Industry 5.0, we are trying to again connect our public with these things. The purpose of that, because of every year the demand of the product product is changing. This year we are purchasing one smartphone. This year we are not getting that facility. Maybe next year we will upgrade many things. So you have to upgrade to self every year. Okay. So in the 4.0 we are using the robot, okay, for the automation. So those robots for the limited purpose. So we cannot change the program of the machine. So what we are doing in industry 5.0, we are changing we are changing the robot, or we are using by the name of the cobot. So the cobot is nothing but collaborative robot. So the purpose of the collaborative robot, we can change the program as per the requirement of the current demand of the market. On that basis, we can change it. So one of the person behind that, or supervisor, or we can say the skilled person will be available at that location. So he may change as per the requirement of the order of the managing director or whatever the authority of that organization. So the social IoT, smart homes, smart schools, rehab system, care for adult and disabled. So now we are also using some of the application for home. So maybe 10 to 20% we are going towards the smart home, smart school, because of in the higher class, or it means the ninth, 10th, the school, in the school the students are carrying the mobile phone, they are searching, or they are doing the classes by the phone. Or we talk about the, especially about the corona, that time most of the people join the classes by the mobile phone. So it was also the part of that. So the smart school. And in some of the schools, as you may look in this figure, they are providing the tablet by which they are doing everything on this. I know many benefits of this, but so many drawbacks of also this. It also affect to your eyes. You are not writing anything by the hand. Sometimes because of our hand, we work with our mind. But if you are thinking something like in the other direction, and you are writing every year or every time continuously, every day, something at least, so you may write without thinking. But in the laptop condition or in the tablet condition, you will not write down. If you will write down a single word, then some places like the intelligent word, if you will write down this, if you are using the laptop all time, you are not writing on the paper, then definitely we will do the mistake here. So something we are losing. So when so this kind of problem is occurring, but we are looking in the direction of what is the exactly benefit of the IoT. In many direction, it is perfect, it is good for the basis of the where is the application of that. And here we can look the smart coding that we are following, the radio frequency identification, RFID, and also this is the community home server is available here, ambulance is connected, so the hospitals are connected, so we can understand the information. And also the our items, the aeroplanes information we are getting, where is the location of that and what is the status of outside pressure, inside pressure, how much the status of oxygen, that we can read directly, or we can send the status of to our server. So the smart city and infrastructure. In this figure, we may look smart public building, traffic control through IoT lights, IoT parking lots, utility management, connected smart cities, and intelligent retail. The biggest challenges in this sector is that everything is already built. So in incorporating IoT would require a lot of retrofitting or rebuilding from the scratch. Both options are expensive, complicated, and many requires year to complete. Another challenge is the sheer size of these projects. So far, we have talked about the agriculture field, a factory, a home, a building, but not an entire city. Managing this upgrade to a smart require collaboration and trust among all players, developer, businessmen, and government bodies. The political will be bill of the nation. Sorry for the interruption. The technology, the political view of the nation, the city will have to make the lead, but the technology provider must be ready to play their roles as well. Leaders of the technology need to be tuned the government plan and align their business strategy to match the government long-term plan. That would be helpful to gain government support in the form of the grant, tax breaks, and other incentives. Let us assume we overcome these challenges by assembling a team of experts that will be helpful for multiple decisions. We fully understood our industry sector challenges. Next, our target to contend with technological challenges such as hardware hardware compatibility, networking capability and limits, and cyber security measures. So next is the technology challenges. So we suffer from the software hardware compatibility. So a number of challenges may be encountered while developing a system of for the specific application, like the compatibility of software hardware. The beauty of IoT is that we can implement it with our choice of technology. Option we can choose the type of sensor as we want. We can structure our data the way as we want. Even we are free to select the data analytic algorithm, that is the TA algorithm, as per our preferable language. Although we can choose the IoT client as we want. Often the technological choice comes down to availability and experience. Developer would choose option they are experienced with and are available to them. The clash comes when people select different or incompatible choice. For example, developer A selects Arduino. It is a one kind of board controller. Arduino as the choice of controller due to their experience with that. However, developer B define the system parameter as too complex for the simple Arduino controller to match. Okay, so the other is problem is the network capability and limit. So in these challenges, network capability goes hand in hand with the required data size and broadcast frequency. As we discussed about the agriculture, we could work with a small data packet and frequency. Setup cost and limitation might force developer to make compromise and concessions. They could be perhaps break the data packets size in half, but make it more efficient or cache the data before the broadcasting. Next one is the problem is okay. So as we understand, I think also in one direction, That is the as we want to compare with that. In the 4G network, it would be 16 minute, approximate the 16 minute to download the 12 gigabyte document. When we talk about the 5G, it would be take 11 seconds. So how much changes? 16 minute to 11 second. And date same date same data we can download from there. With these exceptional capability, 5G is expected to impact every facet of our lives, home, industry, cities, infrastructure, and more. The next one is the cyber security and IoT attacks. So, which kind of technology challenges in this? IoT devices are designed to be simple nodes that performs only one task: capture and broadcast data. This simplicity, however, make these devices vulnerable to attacks and hacking. Also, the data itself being broadcast to the cloud, it could be hacked. This brings the role of IoT cybersecurity and data encryption. The level of security would directly depend on how critical data is. If monetization is employed, then customer would want to know that data is safe or not, or it will be hacked. So this area is perhaps best left to cybersecurity experts because we know about more. We could contribute to adequately defining the data structure to facilitate better security and options. So the effective implementation of the IoT, how we can effectively implement these things. So these steps we have to follow for the supportive, for the better implementation of the IoT. So first of all, we have to think, set the command ground, difference and similarity resources. Define the system architecture. Where is the scope of that sector? Direction, data flow. Define the data structure, needs, inside, formatted raw data, types, size, and what is the data source. Develop the IoT device that would capture and broadcast the data. So it means the things. Obtain setup networking to match system needs. So what is the size of packet data and broadcast frequency? So we have to keep in mind all these 10 points. The develop or select data analytic algorithm to get the insight. Okay, so analytic. Develop IoT client web application as per system, where the architecture and DA algorithm. IoT output protocol for streaming operation purpose, or for the reproducing data purpose, or for the both, or data monetization, as we discussed in the previous slides. The first 3 steps involve pre-analysis. So 1, 2, 3 steps: previous analysis, setup, and making important decisions that would impact the rest of the process. And the 4th step involves metronics, as we are working with direction, the mechanical engineers, the mechanical design. While the 5-step networking system, and the 6th step involves software engineering. The 7th step belong to web development, and 8th step through 10 define how the output of the IoT system are delivering. Okay, so in the following subsections we will discuss. Okay, the innovative solution for the future IoT. So how we can innovate to our IoT system, and I have no doubt, after basic understanding about the IoT, it definitely boosts IoT application technology after the installation of the 5G. 5G network everywhere in India or especially in cities. It will also boost up the demand of the 5G IoT ready products. So where the hyper automation. So what is the purpose of that? It is a one kind of process of combining automation with advanced technology. For example, artificial intelligence, machine learning, and data logger, and robotic process automation as we are using in the industries, mainly in the industry to transform the whole organization rather than just automate a process or a function, where IoT being the glue linking the various processes within the organization. Cloud is moving. So cloud is moving, although functional, so many data is available, but we have to refine to that. On that basis, we can use exactly what data is required. So researchers are investing new technology that cloud change the role of the cloud play in the IoT system or even eliminate it. The motivation behind that is the most of the IoT challenges are cloud related: data security, compliance, broadcast delay, and network issues. Distributed cloud, hyper cloud, multi cloud, private cloud, and even cloudless IoT are active research field in the area. Collectively, they refer to how remote server are managed to minimize cloud related challenges. And the edge computing, it is a one kind of new development paradigm that combines several of these terms and ideas in the post-pandemic and need to accelerate remote system. So, what was the application today and tomorrow? In the current condition, we was implementing the IoT system in the industry and agriculture, smart homes, infrastructure, and the last 2 years we are also working in the direction of healthcare department. But our the testing is already have done, and in the metropolitan cities, the 5G network is already installed. So our expectation is the boost of the connectivity. So that will help, especially for the industry, where we can get the fast response. So so we can convert the or we can point to point data can be get. The IoT to be everywhere, anywhere and everywhere. Possibility in many areas like the retail, services, productivity, healthcare department, predictive maintenance, and logistics, and also the retail industry. So the application of IoT in mechanical engineer, ease of governing the machine, increased communication, strengthening ethics, field testing, imparting the value to digital twin technology, automation, and industrial revolution. So, so the first one was the ease of governing the machine. So in these two figures and the left hand side, this is the oldest one where we was using the mechanical system, and everything we have to look by the naked eye. So we have to always stand there and care what is the going status that we have to stop and on and precisely cutting. But what is the changes comes while after the IoT? In the right slide, the person take the tablet and he fixed everything point to point. So we are talking about the array points or nodes. So point to point we can clarification, so precise dimension we can achieve. So we can get it the precise dimension from the IoT help with the help of IoT. When we are talking about the increased communication, when we talk about the mass production unit time, that time so many people are connected, those are looking and those are handling the machine and assembling the parts in the machine. But later, when we are using IoT based mass production line, there it is found we are using the robot. Those robot are for the specific purpose. When we are using for the assembly purpose, then we may use for that. So it is part similar to the industry 4.0. But when we talk about the 5.0, there we attach the cobots, so we can use for the multi-purpose and also for this the defined purpose. So the strengthening ethics. So what is that? The strengthening ethics. The further the IoT enabled commercial PLM system. What is the PLM system? The product life cycle management that actually, as I discussed in the history, MIT person work on that. So he actually implement on this the strategic process of managing the complete journey of the product from initial ideation, development, service, and disposal until the disposal. So put another way, PLM means managing everything involved with the product from cradle to grave. Therefore, PLM will help in maintaining the ethics sense of mechanical engineers and understand the importance of physical data in the field. So the product life cycle management uses in the following case: connect your product value chain, seamless integrate, driver faster innovation to launch, harmony product data, reduce the cost of quality, enforce product compliance. So imparting value to digital twin technology. So what is exactly this? The IoT can become the backbone of the digital twin type of technology, which contributes to new mechanical design and engineering style, making new digital engineering innovation. According to the mechanical engineers, must access their design engineering based on the physical data in the real world with virtual data with help of the IoT. So what is happening exactly here? This is the our one of the physical system. That system we are taking in our computer. So this is one of the examples. So this is our the computer screen. So we are making the same data. We are taking the response from the actual system with the help of the IoT, and we are saving the data, and we are creating the same kind of things in the computer. So that is the digital twin. So in the other example, we are also doing the same. It is the actual or physical car, and we are creating the similar kind of design and also the distribution of stresses and also many things. So that data we will use for the later factor of safety, and also the so many factors can be resolved. So the next is the automation. In the automation, our smart home, we have the smart home, but how we can do the smart home? The digital control with wireless support made control and automation of large data possible. The machine can lead a faster and timely output and reduce the machine-man interaction, disorganized care. The Internet of Things potential has a lot of to offer for make life and technology easier than ever. So without any second thought, such positive technology is the one of the most people look forward it. So we are taking another example of the smart farming. What we can do in the space currently, we are using the manless or manless fighter planes, and similarly we are also following here the smart farming. So everything is, so no requirement of the man. You may handle your everything from your home. like the plant sensor. So you have to attach what is the requirement. You want to measure the temperature or you want to measure the force. So according to that, you have to decide which sensor will be suitable for that. And on that basis, you may receive the response from the system and deliver the exactly what you want. Or on the basis of past experience, you may arrange everything in the system with the help of the IoT. So the smart farming, like the fisher plant, we want to fish the fish plant, so we can also take help of the IoT, and also for the house or the poultry farm or so many things. So the smart farming, the talk about the third green revolution. What was the status of the first green revolution? That time we used the animal in agriculture. Later part the man is same, the animal is changed or animal is replaced by the tractor or by the mechanical system that we use and we called as the tractor. So and later what is happening in the green revolution 3, there no man is required, only the machine is working everything. What is the requirement of that and what you want to see in the in the farm, so everything you may do. And similarly after the initial and in the growing condition, you may put the suit type of sensor, so they can measure the moisture content and where the which time the water is required and which how much amount of water required, that can be fed automatically with the help of the IoT, because of we are getting the response, we are getting the input and we are getting the response with the help of the IoT automatically or by the manually. So the industry revolution, as I already discussed about the different revolution of in the industry, as we know the industry 1.0, there we was discussing, and that time we implement about the water. It means we are converting or we are getting the energy with help of the water and the steam. So we are getting the mechanical energy in the form of the mechanical energy. Later, for the purpose of the mass production in the industry 2.0 in 1870, that time we use the electrical energy, and that helps to create the similar kind of product for the mass production purpose. And the third automation, there we try to connect the all production sections with a complete automation direction. In the 4.0, the connection with the internet, that is the IoT, and also the so many things by the different using the resources. And in the fifth or 5.0 industry 5.0, there we are actually here the thing centric related, and here we are talking about the human centric. So we are also thinking about the human and how we can get the benefits from that human and to save the environment. So to avoid the okay, so IoT, what are the IoT challenges? The first is the security of data. It means the security of data, privacy and data sharing issue, because IoT devices are closely connected. All the hackers has to exploit one vulnerability to manipulate all the data, rendering it unusable. And manufacturers that do not update their device regularly or at all leave them vulnerable to cyber criminal. However, hackers are not only the threat to the Internet of Things. Privacy is another major concern for the IoT users. For instance, companies that make and distribute consumer IoT devices could be used those devices to obtain and sell user personal data. The challenges with the IoT, that is the security of data, as we discussed before, the reliability and stability of the IoT sensors, they are giving the same response or not. So we have after a long time or after a specific interval time, we have to standardize or to check the status of that sensor. Otherwise, maybe the response after some time is changed. The connectivity of all system in IoT setup, no maintenance, blending legacy system IoT, industrial IoT is new in the market. High frequency. Obviously, we can get the many things with help of the 5G network. So many researchers work in this direction. They describe or they mention in the direction of 5G research that will be harmful for the animal at birds. So, what are the advantages of the IoT? IoT provides the following benefits. First, improved customer engagement. So, what did you mean of that? IoT facilitate a better customer experience by automating tasks. For example, in a car, for instance, any issue will be detected automatically by the sensors. It will be notified to both the driver and manufacturer. Technical optimization. IoT has improved technology and made it more efficient. It has turned even dumped product to the smart one by making them able to transmit data over the internet, facilitating communication with people and other IoT enables device. For example, the coffee machine, smart toys, smart microwaves. The next point is the ease of access. So IoT has now enabled access to real-time information. What is the going on inside this from the any location? All the needs is a smart device connected to the internet. The improved insight, the meaning of improved insight. Currently, we rely on superficial insights to make the decision, but IoT provides real-time insights that lead to more efficient resource management. For example, something the accident is happening. That time we always think what was the cause due to which this accident is happened. So we analyze many things. If the sensors are available, is there, then we are watching at every milli of second, so we can get the response from that specific object and we can receive the data. Then we can directly understand what happens and where was the fault of the machine. So the new business opportunity. So what we can do by collecting and analyzing data from the network, you can uncover new business insights and generate new opportunity while reducing operational cost of the product. Effective time management. Overall, Internet of Things can save you a lot of time while we commute to work. We can read latest news on your phone, browse a blog about the favorite hobby, or shop online. Improve security measure. Using IoT, access control system can provide additional security to organization and individual. As an example, IoT technology surveillance can assist in improving security standard in your organization as well as identifying any suspicious activity. So the required component and software for the IoT system. So first of all, we have to know about the primary focus in the direction of production and distribution of electricity for the energy source to end users. The analysis involved in electrical system involved in includes generation, transmission, distribution, storage and electrical power management. In electronic system, the primary focus is the management and transmission of data. The analysis involves system and machines for the capturing data with the help of the sensor, processing data by the controller, and performing action based on the data that with the help of the actuator. So these four parts very important. One is the sensor, controller, and actuator. So hardware abstraction. Hardware abstraction is the process of linking hardware to software. It is process of defining hardware element such as a sensor or actuator or an object as an object in the control program, thus allowing to us interact with it. So what is the basic difference between the program and algorithm? Although the term program and algorithm are related and seems similar, they are in fact different understanding. That difference and using that understanding when creating controller program is a powerful skill of any developer. But what is the algorithm? Algorithm is a one kind of written language in a human language where we can write down in English, Spanish, and also your native language. As we can see in this, we are writing in the English. So the algorithm, so it is little bit easier to write down. Otherwise, here we have to follow the all point-to-point steps, standard steps. Otherwise, program will not run. But due to the cost of the C programming, C++ programming is less, but algorithm is a little bit costlier. And embedded system, microcontroller based system. So embedded system is a microcontroller based system where a controller with sensor, actuator and miscellaneous component as we can see in this figure and embedded into another system to perform a dedicated function and add the functionality of to the host system. So here the many parts is available and these are the three types single. That time I was talking about the microcontroller and which kind of controller we may use for the IoT purpose. And this is the figure is representing to the industrial robot with the help of the embedded system for the industry 4.0. So these are the main three types of embedded microprocessors: single chip microcontroller embedded system, single board microcontroller embedded system, and single board computer embedded system. So the purpose of that, so which kind of information we want, on that basis we choose. For the simple purpose we use the single chip microcontroller embedded system. So these are I take from the two different company. So normally we use our students the Arduino Uno controller board. This is the cheaper one, and we can get the program from the internet. So many sites are available, or especially by the Arduino. This also provide the program, so directly we can download and implement in the system. So no need to write down the program for that. But in the Raspberry Pi 3, you have to, or we have to write down on the C++, and also we have to specify for this. And this is not free or not the open. So due to that, some of the limitation with that. But what is the exactly purpose? We want to use for the single purpose or for the multi-purpose, or what is the status of the technology? When we talk about the Raspberry Pi 3 system and we do the comparison here, the internet Wi-Fi Bluetooth facility is available, so no need to purchase the other thing. But here we have to purchase in the Arduino system the extra module for that. And the limitation of any Linux support IPD, any programming language can be used here.
In the Arduino system language C++, C++ we can use, but it is much easier because of these program is already provided by the Arduino, so we can download for the specific purpose and we can add it to them for our application purpose. Okay, so thank you very much for your kind attention. This is my information where you may contact for any kind of doubt or later information in this regard, IoT or Industry 5.0 or 4.0. Thank you, Professor Ramchandran, Ramakrishna ji and Professor Raghu Kumar. Thank you very much.
Yeah, thank you, Dr. Sanjeev, for your wonderful session and well-made presentation, and let us enlighten us, me and as well as the participant with your sound knowledge in this topic. Yeah. So, any questions from the participants? Please don't hesitate to ask. Please clear yourself.
Yes, I will provide the soft copy of the session. Yes, sir. I will send you Professor Ramakrishna, sir. So you may collect from.
Yes, sir. So, dear participant, as the speaker is available with you now, please clear your doubts, whether it is small or big. Don't hesitate to ask him, because this is the only opportunity you can directly
And
contact.
later also we can work in this direction. If actually these are the colleagues, all are the faculty members, so definitely we can collaborate the work. Maybe you may knowledge in this direction more, or some places maybe I know, but every time we have to learn more things about that. So I think Ramakrishna sir, no one is asking, so please let me know the next step.
Okay, Dr. Sanjeev Kumar ji.
Thank you, sir.
Thank you very much, sir, for your session, and the basic fundamentals of IoT. We have just enlightened the basic fundamentals of IoT, starting from the basics to what is IoT, what are the various applications of IoT, household applications, then mechanical applications. You covered the wide variety of IoT applications, sir. Thank you so much for enlightening us with your presentation. Thank you, one and all. Thank you so much,
Thank you
Dr.
very much, sir. Whenever you have the time, you may visit my NIT Raipur.
Please, sir.
I
Please,
always
it's my
welcome
pleasure.
you.
Thank you, sir. It's my pleasure. Thank you.
Yeah, definitely we will collaborate, sir, and we will definitely visit one time in NIT Raipur.
Yes, definitely. All time our doors are open.
Yeah, thank you for that.
Yes.
Yeah, in future we may invite you for the physical presence also into our college.
Yes, sure. That time definitely I will come.
Yeah, okay. Thank you. So, dear participants, we have shared the feedback link in the chat box, video link chat box. Please fill that form before you leave the meeting session.
Yeah, before leaving, my dear esteemed participants, there is a small announcement. As most of you know, during the offline sessions, there are two sessions on article discussions, Article 1 discussion and Article 2 discussions. We will divide this into some of group, and each group has to discuss on the paper that we are going to provide. So to make that process is easy, we are providing those two papers tomorrow through our WhatsApp. Please download, take a printout, start reading, and that will be helpful during our offline sessions. Okay, so that discussion will be there, and some of you may need to present that also, teaching practice. So to make that entire process is a seamless and very smoothness, so tomorrow in WhatsApp we will provide two papers on IoT.
Okay, sir. May I leave?
Yes,
Sir,
you can leave.
Dr. Sanjeev.
Okay, sir. Thank you very much, and good night to all of you.
Yes, sir. Thank you and good night. Dear participant, if you have any doubt, please raise your hand and let's clear now itself.